Hello, everyone, and welcome back to the Cosmic Hour. I'm your host, Aarav, and today we're diving into a topic so massive, so powerful, and so deeply connected to our daily lives that we barely even think about it. I'm talking about the sun, the giant blazing sphere that literally makes life on Earth possible. And to guide us through this cosmic journey, we have our expert guest, Mia, astrophysicist, science communicator, and a brilliant storyteller. Mia, welcome back.
Thank you, Aarav. Always excited to talk about the universe, and especially the sun, our personal star, our heat lamp, our clock, and our life source, all in one.
Let's start with the most basic question. What is the sun, really?
Great question. The sun is a G-type main sequence star, commonly called a yellow dwarf, even though it's actually white seen from space. It's about 4.6 billion years old, made up of 74% hydrogen, 24% helium, and the rest are trace elements like oxygen, carbon, neon, and iron. Inside the sun, hydrogen atoms fuse into helium, a process called nuclear fusion. Every single second, the sun converts 600 million tons of hydrogen into helium. That's like detonating billions of nuclear bombs every second, but in a controlled process.
That's wild. So it's basically a massive nuclear reactor floating in space.
Exactly. But the best kind. Clean, stable, self-sustaining, and far enough not to kill us.
So the fusion happens in the core. But how does that energy reach us?
That's the crazy part. A photon, the particle of light, takes 100,000 to 1,000,000 years just to escape from the sun's core to its outer surface. After escaping the surface, it only takes 8 minutes and 20 seconds to reach Earth. So the sunlight hitting your face right now started its journey when early humans were still evolving.
That feels like time travel light.
It absolutely is.
Walk us through the layers of the sun. How is it structured?
Sure, think of the sun as a giant onion with 6 layers. Core, 15 million degrees Celsius. Nuclear fusion occurs here. Radiative zone, light slowly diffuses through, takes thousands to millions of years to pass. Convective zone, plasma boils, rises, cools, sinks, like a cosmic lava lamp. Photosphere, the surface we see, sunspots appear here. Chromosphere, a reddish layer, solar flares originate. Corona, outermost layer, over 1 million degrees Celsius, temperature mystery, hotter than the core surface.
Why on earth is it hotter on the outside?
We don't fully know. One theory suggests that tangled magnetic fields snap and release massive energy. The sun has mysteries we still can't solve.
Why do we depend on the sun so much? What would life be without it?
Without the sun, Earth's temperature would drop to negative 273 degrees Celsius. Oceans would freeze, photosynthesis stops, no oxygen, weather dies, ecosystems collapse. Every bite of food you eat is basically repackaged sunlight. Every breeze, every raindrop, every season, sun-powered.
So the sun isn't just important. It is everything.
Exactly.
What about the dangerous stuff? Solar flares, storms, CMEs?
The sun isn't peaceful at all. It's violent, chaotic, and constantly exploding. We have 3 main events. 1, solar flares. Sudden bursts of radiation can disturb radio communication. 2, CMEs, coronal mass ejections. Billions of tons of plasma thrown into space, if aimed at Earth, turn into geomagnetic storms. And 3, solar wind, a continuous stream of charged particles, creates auroras on Earth.
What's the worst case scenario?
A massive CME directly hitting Earth. The 1859 Carrington event melted telegraph wires. A similar event today could knock out GPS, destroy satellites, collapse power grids, shut down the internet for months.
Basically, modern world is fried.
Pretty much.
Why have humans worshipped the sun forever?
Because even without science, they knew the sun meant life. Egypt, Ra, the sun god. Greece, Helios. India, Surya, Gayatri Mantra. Japan, Amaterasu. Aztecs believed the sun needed fuel. Every civilization placed the sun at the center of existence, long before science proved they were right.
Is our sun normal, average, or special?
Scientifically, very average. But for us, perfect. Bigger than 95% of stars, most are red dwarfs, smaller than giants, stable, predictable, long lifespan. It's like Goldilocks. Just right.
What will happen to the sun? Does it ever die?
Oh, yes. Stars live, burn out, and die. Timeline 5 billion years. Then the sun will become a red giant. It will grow so large it may swallow Mercury, Venus, and possibly Earth. After that, it will shed its outer layers, then shrink into a white dwarf, slowly cool for trillions of years.
So Earth is temporary.
Everything is. But we have billions of years, enough time for humanity to evolve or move to new worlds.
Who's studying the sun today?
There are several brilliant missions. NASA Parker Solar Probe, the closest human-made object to the sun, Solar Orbiter, ESA, SOHO, Hinode, SPHERX. We're learning about solar winds, magnetic fields, plasma physics, and solar cycles.
And from a practical perspective, how will humans use the sun in the future?
Solar power is the cleanest source we have. Future may include space-based solar power satellites, solar farms on the moon, Dyson spheres or swarms. Sci-fi today, maybe reality later. Solar-powered space travel. The sun provides 10,000 times more energy than humanity uses.
Before we map, give us some fun sun facts.
Sure. The sun contains 99.86% of the solar system's mass. A pinhead-sized piece of the sun would kill you instantly. The sun rotates at different speeds, equator versus poles. The sunspots are cooler, but still hotter than lava. The sun makes Earth's clocks, seasons, weather, life cycles. Without the sun, Earth would be invisible in space. A frozen rock.
That's insane.
Mia, thank you for taking us on this incredible journey into the heart of our star. The sun is something we see every day, but we rarely appreciate how truly powerful and mysterious it is.
My pleasure. And yes, the sun is ordinary in the cosmos, but extraordinary for us. To everyone listening, thank you for joining us on the Cosmic Hour. Stay curious, stay inspired, and next time you feel the sunshine on your face, remember, you're feeling the energy of a star that fuels everything you know. Until next time, goodbye from Aarav and Mia.